Welcome to another episode of Young Entrepreneurs with the Green Roof Team. My name is Nelson Fernandez, and today we are here with Devon Cantrell. How are you doing today, Devon?
Oh, I'm doing pretty good. Just got off a long day of work, but I'm home now, so ready to get into it, ready to get going. How are you doing, Nelson?
Going pretty well. It's a bit of freezing rain outside, so not all too much fun. I know the drive home from the university was a bit difficult with my windshield getting all iced over. And I forgot that the car has a de-icer. So it was a quite interesting drive. But otherwise, going pretty well. So, kicking off today's episode, would you like to tell the audience a bit about yourself, some of your interests, hobbies, what you like to do?
Okay. My name is Devon, as you probably know, but yeah, I'm an engineer at the Boeing company, Boeing Defense, up in St. Louis, and I've been here for about a year. So I graduated Carbondale, SIU Carbondale, last May as an electrical and computer engineering major. So that's what my degree's in. And I'd say that's sort of my main area of study and interest is relating to that, mainly VLSI technology and analog technologies in terms of electronics. So a lot of that has to do with making really small computational circuits and arranging them in different ways. So um, basically, just that kind of has to do with anything like your phone or your computer or microelectronics. That's sort of one of the areas I have a very strong interest in. But other things related to engineering and a lot of things outside of engineering too. I'm a bit of a history whiz on the side. Um, read some Latin, things like that. Just other stuff on the side to get a little bit of class in me, you know. Try to be well rounded, do some cooking. I do a lot of video gaming too. Probably takes up a lot of time. I should probably devote more time to other interests other than that. But yeah, kind of just a whole well-rounded area of different things.
So you mentioned history. I know
Yeah.
from our conversations they're always quite interesting. Are you interested in like the history of like things like buildings, architecture, poems, writing?
All sorts of that, really. I can quote a bunch of old poems from hundreds, thousands of years ago. I kind of a history. I again, I mentioned I like the game. I like to get on and build old historical, like Dutch style cities and stuff like that. With the architecture, that's really pretty much all I use Minecraft for. Is just building different types of architecture.
Sweet.
So
Nice.
it's
So diving right into today's episode. So I heard that, and I know from experience that you were part of the team that was able to get this wind turbine up and installed, right?
yeah. Actually, if you go on the post, one of them, I can't remember if it was one or all, but there's a picture of me leaning up against it, and that was the day I believe Nelson, you and I were there putting those props on, or one of the days, because I'm pretty sure you took them off a few times. But yeah, I remember being there putting that together. That was an experience.
Oh yeah, it most definitely was learning and making sure that all the cups and the blades were able to easily be moved on and off so our team members could learn more about it. So would you like to dive right in and talk about what your role was on the team with the wind turbine, the design, the installation?
Well, yeah, part of my goal was to get some actual experience making a real product. It didn't matter really how good or how bad the experience was at first, although this ended up being better than most for in terms of college students go. I just needed to, be out there working with real stuff, putting something real together rather than in the classroom doing fake stuff and getting a curve on the grade or something. Trying to make something that actually works, because in the real world, that's what makes money. That's what people are interested in.
Most definitely. You can't fly a plane if there's no plane, and it's all calculations.
That's true. So that's part of why I got on there. And then the reason I'm staying with with it is because there's a whole bunch of different avenues opening up, and one of them is I'm really getting passionate, and whenever I'm really going to try to push this idea of making gravity batteries out of like koi ponds or something, because I still feel like that's a golden idea, and we can try to do some energy storage, but also other things too. So the fact that the green roof looks to have a direction of just continually doing a bunch of different research up on the roof over in the ag building makes it that's the reason I'm staying with it. So, and also I got some experience now making stuff, so I figure I can bring that back to some of the new people who are coming up with electronics and maybe help out with the actual hands-on. So yeah, it's pretty much just the combination of new, exciting uh, areas where this can go, and also mentoring new people. So looking forward to it.
Sweet. And I know we're gonna have so many more opportunities for you to become a mentor and a coach, new members in the coming months. It's gonna be exciting to see how we grow and develop all together.
It will be. Because see, that's the great thing about Green Roof now is it looks like it has a future. So it's gonna take some commitment. So we need folks to we need younger folks to come up and want to be the water that waters the seed, I suppose, part of the water.
Oh, just like an African violet plant.
Yeah, a lot like that. Or I can be like the food, the nutrition that goes into it, like all plants need it, even African violets.
So with this wind turbine, we're going to talk a bit about what the electrical system entailed and what your part was in getting it actualized.
The fan spins a lot when hopefully a lot if it's windy, so we can harness the energy. That energy gets transformed into electrical energy by the generator that the fan blades are spinning through electromagnetics and all sorts of process like that. And out of that, it'll come. In most countries, it's done because the most efficient way to do it. There are three different phases, so you have three different wires. Pretty basic here so far. So we just basically we wired those. A lot of the time was actually spent trying to figure out how to get the cable and wiring through the conduit. If you can remember, Nelson.
So we had the 12 gauge wire come from a generator inside the mount. It ran all the way down, and then we had we had flexible PVC pipe to help protect it from the weather. So flexible PVC pipe.
Heck yeah. And did we use power sensors? I can't remember. Did we use an IC squared sensor in that one as well, and different stuff like that with the Raspberry Pi?
So the name that we call it is INET-U60 sensor, but I believe they're one the same.
Okay. So yeah, it was basically just rigging that up to monitor. I think all we did was monitor the power, right, last year.
The battery health.
Oh, okay, the battery health. It did go because it was in the battery box. So yeah, everything just fed into a big box that was supposed to be weatherproof.
It was weatherproof, actually.
It was. Oh, I thought the first prototype got flooded with water.
Oh yeah, the first did, but the second and third did not.
Oh, okay.
Those are small
yeah,
wins.
those stayed alive. And then basically just more or less that was pretty much it. Pretty simple, but pretty important concept.
Most definitely. So, taking a good pivot, you mentioned coaching and mentoring earlier.
Yeah.
On the podcast. Do you have experience in those areas?
A little bit. I was a part of the leadership development program down there at Carbondale for a while, and everybody who goes through that program ends up mentoring and coaching a little bit in something. Usually in leadership, but sometimes something else. But I'd say that's where I got a lot of my experience from. But also, I did lead the radio club down there as well, and we went out. We did trips like that, try to grow people's knowledge, especially my younger brother. But he was somewhat more of a difficult guy to work with on that. But we eventually got him into it, making radios and a little bit of electronics. He's not really an electronical background. Well, he's got a little bit, I guess. But yeah, I got some experience pretty much mentoring, but really, it doesn't matter how much experience you have or something if your goal is to like get to the point where you're mentoring one day, because everybody starts off as like, an infant or something who knows nothing. So you got to learn by doing. So jumping in there and then watching other people like obviously Alex, of course, he's a super smart dude, but like I guess he's in Maryland or wherever he's at, so he can't physically be there. Which kind of I guess sucks for us, but yeah, I try to learn from him and different technical aspects that he knows, and try to use some of my expertise from actually working a little bit to take what he knows and apply it in the physical real world over here in Illinois. So yeah, I got a little bit of experience, I guess, just to sum it up, but not a super whole lot. I wouldn't say. I wouldn't claim to have a lot anyway.
Sweet, but at the end of the day, it all comes down to being able to share what you know to others and helping them get to a higher level of knowing, right?
Yeah, more or less. That's pretty much the goal. Different ways to do that. You can just tell them. You can yell at them. You could just go out and show them. I mean, it's a lot of different ways. Students are smart. Mentors are smart. Teachers are smart. Everyone's one of those things all the time. So remember that you're always a mentor. You're always a learner. So there's no such thing as really as these labels being hard fixed. So yeah, I'm not really too super worried about that, because I know Steven's pretty smart, and he's if anything, if I try to show Steven how to do something, he'll teach me something about staying on track, and then he'll probably actually read the book or something if we're in a class or something. So that's the thing. That's the thing. Sometimes your students or your mentors or whatever are smarter than you. That's just an example, by the way. But Steven is a pretty on track guy, I will say.
That's a great lesson to take away on how, even though you might have higher seniority than someone else, they can easily teach you something that you didn't think of or have not experienced before. It's a great lesson to take away.
Indeed, they're always doing it. So,
do you have any other lessons that you learned from during your time in the past few years involving coaching, mentoring?
well, just strictly on a coaching, mentoring level, just aside from everything we've been doing. The one lesson I learned, if you're actually just going to coach somebody, is they kind of got to want to be coached. I don't think that's a problem with like anyone, really. Most engineers or smart people, really, because I think they understand the value at a deeper level. But every once in a while, you find somebody, if you're coaching, and it's not always the person too. Sometimes it's the coach who sometimes they just don't like fit together, or their vibe. Pardon my lack of a better word. Their vibe isn't quite right, and they really both kind of got to want to be there. Kind of got to look past the differences. But really, if you want it hard enough, then there really shouldn't be any. It shouldn't be impossible to have a productive relationship in that manner, if you know what I'm saying.
Most definitely. It needs to be a relationship that's mutually agreed upon and is accepted by both parties.
Yeah, exactly.
It's kind of like if I ask you to do something I know it's out of your scope and out of your passion field, it's not going to be too interested. But instead, if I propose and I'm like, hey, Devon, could you look into the semiconductors and this type of battery? And I can already see like your eyes will light up and you're going to go after it because it aligns with your values and what you're interested in, right?
Yeah, it aligns with the interest stuff. But yeah, I'm always down to go with interests and things like that. So yeah, I'd always look at power electronics are pretty cool. So I dive into that. Silicon, high wattage and stuff. That stuff's cool, dude.
Sweet. So, what other books have you been reading lately?
Well, recently I've cracked into. Well, I got one from work that I was reading at near the end of my shift on analog electronic design. It was this old one I found, and it's kind of in the introduction right now, but it's more or less just about different aspects of analog electronics written by this or by like three different professors or something. But yeah, that's what I'm reading now. And then I don't like read one book at a time. I kind of get into one, pause, and get into another one, pause. Have like a bunch of different going at one time. But here's another one. My other more recent one is this one on the fractional calculus from Gustavo on the team. I don't know if he's a co-leader or what is he, a leader, co-owner or what. He's something higher up on the green roof. But Gustavo told me when I think it was his master's when he was getting that he was if you know a lot of if anyone knows anything about control theory and engineering, you use a lot of calculus for different like proportional integral controllers or proportional integral derivatives, and you just add all that math together basically to really dumb it down to get it what you want the system to do, the kind of oscillations and things like that. But I never heard he did work on a 1/2 derivative proportional controller. That's probably wrong, but I was looking at it and I was like, oh, that's pretty cool. And like the applications, and he's like, yeah, it's based off some fractional calculus. I'm like, oh, fractional calculus, you said. I've never actually done that or heard of it. So I looked into it, found a book, and bought a book, and I'm getting into that a little bit. It says theory on arbitrary integration to arbitrary orders or whatever. So I know I just horribly butchered that title and it's right in front of me, but it's the end of the day, so whatever. But yeah, it's gonna learn a little bit about that, try to understand it. Probably won't at the first time. That's why we have teachers. Wish I had a teacher for this though, but yeah, it's kind of like what I'm reading now. It's a little too technically, I feel like right now at the moment, but those are the current newest reads on the manifest. What are you reading, Nelson?
Thank you for asking. So lately I've been reading a book. It's called From the Cubicle to the Cloud. And essentially it's about a woman who started a online business quite a few years ago, focused around accounting and CPMs. So doing taxes in a virtual setting. And it's completely a virtual business. And just going through lessons she learned from understanding how to delegate tasks to setting up scope of work, onboarding individuals, to the logistics of what it means to be a leader versus a manager. And it's an all-encompassing book that goes through lessons she learned starting her own virtual business. And that's something in my own interest field.
Okay.
But going back to fractional calculus, Devon, what's a few of the applications you can have from there aside from control systems? Do you know?
Well, I'd imagine it'd be just the same as any calculus. I haven't actually looked at the applications yet, in all honesty. But where do you use calculus, Nelson?
Where do I use calculus? Well,
Yeah.
aside from, wow, that is an excellent question. Aside from probability and statistics, not too many places in application.
Oh, really? Oh, I actually use it a lot. I sometimes I find the volumes of these cans using calculus and stuff like this can. I'll like trace it out and do like a, what was that where you revolve the make the graph and you revolve it around the y-axis?
Oh yeah.
The wedding cake method, or the what is it, the washer method? I can't remember now, but that's how I used to like solve the areas of these cans and the volumes. Or with like power and electronics, I'll just like get a line of how the like power and energy is going over time. I'll like draw it out. It's like, oh, the power is going slightly up like this, or the energy or what have you. And it's like you can kind of, sometimes it's jaggy, so you got to kind of segment it down, and then you just kind of approximate, and you can do an integral, and then you find the energy during like that time frame. You can kind of approximate by adding together. So like those are just two areas where I use it. I don't know like how to apply fractional calculus to that yet, but there's probably some cool ways to do it. Well, that's not really useful. I read a book on infinitesimal calculus as a freshman, but that really doesn't help in my practical life. But it's cool. It's fun to think about. Infinitely small
Interesting.
areas and stuff. But yeah, I'm just kind of giving areas. Hopefully the fractional type of this will help out a lot. But maybe it will. Maybe it won't.
Mentioned earlier on in the episode about analog devices. Would you like to go in depth about that subject?
Well, you know what the analog versus digital or analog versus discrete.
I do, but our audience may not.
Well, in theory, the most purest form of the word, a discrete signal is where there's only there's not arbitrary. There's only specific, like I guess you could say integers are discrete, but I guess they go to infinity. All the integers between 1 and like 5, that's a discrete set because there are only 5 of them, or 4, or if you count 0, or 6. Anyways, that gets down to your definition, but there's only a certain number of them that fit a definition because they're integers. Now, if you include all the real numbers between 1 and 5, that goes to infinity because you can get arbitrarily small. So if you look at a signal, and in electronics, you have these signals. A digital signal, you'll have a lot of times 0 volts and plus 5 volts as your 0 and your 1. Ones and zeros. There are only 2 possible states. If it's in between, it could really be read as either one. But generally, it's just 1s and zeros. I guess there's don't cares too, but 1 and 0. And then in an analog, so that'll be a block-shaped graph. Up, 1, down, 0. Just very square shaped. In analog, you can have anything in between, so it'll be more rounded kind of curve if you're looking at this on a graph or scope. And it gets pickier and stuff. You kind of design circuits to get specific values on that curve and stuff like that. It's not just 1, 0, because with that you pretty much just use logic more or less to design those. Just logic, 1s and 0s, truths and falses, truth tables. But the other one, you got to do some like more advanced math. You got to sit down and think about it too.
So, talking about analog devices, have you worked on any or designed any or looked at deeply any that our audience members may have used in their daily life?
Any of our green roof members used in our daily life? No, probably not. It takes a great deal of expertise to design those things, and I'd imagine if I could, I'd probably be making multiple 6 figures, or at least over 6 figures easily. Yeah, they're not really super heavy. A lot of things just either go digital or basically I'm saying is no, I haven't designed any that anyone actually uses yet. I'm pretty sure I'd probably need a master's degree or something like that to actually do it. Something like that. Because I don't know enough about them to design something that would be implemented and practical for a lot of people's everyday and like work reliably enough for them to use it. Because I can make something analog, but it's not very reliable. That's just my thing. I don't have enough experience to do that, but that's part of the reason I like him so much is because there's a haze of unknown. So I don't like that. So I kind of want to be able to do that. So that's kind of like my interest where that comes from.
So, thinking about experiences you had in the past, Devon, do you have any lessons learned from building or being part of different team cultures?
Part of a lot of dysfunctional teams at like different jobs and stuff. The one I have now is pretty okay. They're pretty good. But no. Pretty much to sum up what I'm saying is don't be afraid to have a communication or an honest human connection in a team. Don't get overly stuck with the rules unless they're there for like a good reason. Always be willing to, well, for one, just understand your team, understand the other person. Don't assume the worst. Just assume that they're a dude or a gal who wants what's best, and just start from there. Just keep your emotions in check, and you should be fine. That's pretty much if you have a team like that, you don't need any rules governing like team norms. So just respect other people. That's pretty much all I gotta say. If you have to keep establishing rules about this, then your team probably needs some more bonding or more interaction development, because it's been my experience anyways, when you need to start adding different professional, like how we're going to talk to somebody and stuff like this, then that's a sign that your team's not really in lockstep or in lock sync, that some people more understanding is probably needed.
So coming towards the end of today's episode, do you have any final lessons you would like to share with the audience?
Yeah. I've noticed we're getting divided well, for practical reasons, it makes sense. So I'm not saying it's a bad thing, but what I will say is I noticed we're getting divided into different sub teams with mechanical and electrical and different expertises, which again, I'm not saying is a bad thing. I'm just trying to say this, branch outside of that, outside of like once you get your responsibility done inside that core area, because no expertise is wasted, no knowledge or education is ever wasted. I work at an electrical engineering division of a company. I had a guy sits next to me for this project. They were sitting down doing mechanical calculations, and then they used their knowledge of covalent bonds to know which kind of coolant to run through the system and stuff like that. And they have a background in physics to do this. It's like if you really think about it, it's completely arbitrary because they're all part of the natural world. They all affect each other. So it's stupid to like think they're completely separate. Just know that they're not separate. What you do in one team will affect another. And that's pretty much my advice. I have loads of mechanical engineering, some biology, other different types of science texts that I occasionally get into to peruse out of curiosity when I'm not doing my electronics or history or other stuff studies. So that's just my big takeaway is find occasionally something that you're not an expert in and learn a little bit more about it. It'll probably help you out a little bit in the future. There we go. That sums it up. That's what I want to say.
A great lesson. And with that lesson, we conclude this episode of Young Entrepreneurs with the Greener Team. Today we spoke with our team member, Devon Cantrell.
Heck yeah, boys. Good to be here. Hang out.
Stay sustainable, folks.